Hello, in this video we're going to learn about how to find the dot product of two vectors and the angle between two vectors. So first let's discuss dot product. Dot product is the only way that you can multiply two vectors. And whenever you find the dot product, when you multiply these two vectors, you are going to end up with a scalar answer, meaning your answer will no longer be a vector. Your answer will be a single number. So make sure anytime you find the dot product that your final answer is just a simple number. The formula for dot product, if I give you the vector u and the vector v, you're going to multiply the corresponding components, and then you're going to add those products together. So you're going to multiply both of the horizontal components, the x's, together. You're going to multiply both of the vertical components, which are the y's, together, and then you're going to add the two things you got from multiplying, you're going to add them together. So let's look at an example. Here we have u is 5 to negative 3 and v is 2, 4. So we know to find the dot product, u dot v, we don't say u times v, this is called the dot product, so we say u dot v. We need to multiply our horizontal components, x, which is our x's. We need to multiply 5 times 2. So we're going to multiply 5 times 2. Then we're going to then there's a plus, and then we're going to multiply our vertical components, which are our y's, which is negative 3 and 4. So now 5 times 2 is 10, and negative 3 times 4 is negative 12. So 10 minus 12 is negative 2. So our dot product of u and v is negative 2. Please note that my final answer is a simple number. It is a scalar value. It is no longer a vector. I hope you're listening to the terminology I'm using as well, okay? We are advancing and scaffolding our terminology. We understand that scalar is a number. So if I tell you to have a scalar value, you understand that I want a simple number answer. Okay, in this example, I've given you three vectors, u, v, and w. Here, I want you to find u dot v dot w, okay? So the first thing we're going to do is we're going to follow our order of operations, which is u dot w is first because we have to do parentheses first. So u dot v is, remember, I need to multiply my x components together. 5 times 2 is 10. And then I need to multiply my y components together. Negative 3 times 4 is negative 12. And 10 minus 12 is negative 2. Okay, if you need to see that dot product slower, rewind the video to the previous slide and you'll see me break that down a little bit more. So now I can rewrite this entire problem, u dot v times w, as, I wrote negative 12, negative 2. Okay, so I can say negative 2 times the vector w, which is 2, negative 1. Now, in a previously in this unit, we have found, we learned how to multiply a vector by a scalar. So we learned that we just have to distribute it in, just like we did with matrices. So negative 2 times 2 is negative 4, and negative 2 times negative 1 is positive 2. Therefore, our final answer, u dot v times w, is negative 4, 2. Now, notice that our final answer is a vector because this component here of the problem was a scalar and we were multiplying it by a vector, which meant we were going to get a vector answer. Okay? And the reason why I break that down is previously I've seen a lot of problems when students don't know if they're supposed to have a vector answer or a scalar answer. So in this case, because we multiplied a scalar times a vector, we produced a vector. All right, let's look at another example. We still have the same vectors, u, v, and w. This time we're going to say 3u times v. So dot V. So the first thing we need to do, following order of operations, is we need to multiply U by 3. So 3 times 5, negative 3. So this 3 is a scalar, so 3 times 5 is 15. I'm going to use correct notation. I'd accidentally written a parenthesis. And 3 times negative 3 is negative 9. So 3u is a vector because we simply multiplied the scalar 3 by the vector u. Now we need to find the dot product of 3u and v. V is 2, 4. So to find the dot product, we are multiplying our corresponding components. So our x components are 15 and 2, which is 30. And our vertical components are negative 9 and 4, which is negative 36. Okay? And 30 minus 36 is negative 6. So 3u dot v is negative 6. So that is our final answer there. Here, we multiplied a scalar times a vector. Let's break it down so we can determine what kind of answer we're supposed to get. So we had a scalar times a vector, which is going to produce a vector. And then we had a vector dot vector. And since that was the actual dot product, that's going to produce a scalar value. Okay? So I just wanted to break that down so you could continue to see the difference. In the previous example, we ended up with a vector, and in this example, we ended up with a scalar. So you can see the process of checking, making sure you arrived at an answer that is at least in the correct form. Okay, let's do another. Okay, now we're going to begin finding the angle between vectors. So this is only whenever our angle is not 0. So to do this, we're going to use the formula cosine theta equals u dot v all over the magnitude of u times the magnitude of v. So we have learned in this video how to find u dot v, and previously we've learned how to find magnitude of vectors. So we're going to start putting all of this stuff together. So let's look at an example. We want to find the angle between u and v. So looking at our formula, we need to find u dot v. We need to find the magnitude of u, and we need to find the magnitude of v. So let's do that before we even start trying to use the formula. So u dot v, remember, dot product is multiplying corresponding parts. So 2 times 3 is 6. 4 times 1 is 4, so I'm adding that. So u dot v is 10. Now, let's find the magnitude of u. Remember, magnitude is talking about distance. So I have to use a square root, and I'm going to square my x component, which is 2. Then I'm going to add it to my y component squared, which is 4. 2 squared is 4. 4 squared is 16. 4 plus 16 is 20. And the square root of 20 is 2 square root of 5. Now we need to find the magnitude of v. So remember, I have the square root of my x component squared plus my y component squared. My x component is 3. My y component is 1. So 3 squared is 9. 1 squared is 1. So 9 plus 1 is 10, the square root of 10. The square root of 10 does not break down, so we're going to leave it just like that. So now let's dive in and start plugging into our formula. U dot v is 10 all over 2 square root of 5, because the magnitude of u, times the square root of 10. That is 2 times the square root of 50. And the square root of 50 breaks down to 25 and 2. The square root of 25 is 5. The square root of 2 is 2. But don't forget, we still had this 2 out front. So then we have 10, because 2 times 5, 10 square root of 2. So now we have 10 over over 10 square root of 2. Our 10 simplify out, so we have 1 over the square root of 2. And this is all cosine theta. I forgot to keep bringing that down. I got carried away with simplifying the right-hand side. And to make this even more recognizable, that's cosine theta equals the square root of 2 over 2 to get whenever I rationalize my denominator. So I noticed that I've seen square root of 2 over 2 quite frequently, and that is on the unit circle. So what is our angle measure on the unit circle where cosine, our x value, is the square root of 2 over 2? It is 45. Now, what happens if we have cosine theta equals a number that's not on the unit circle? So what would we do then? Well, what we would do is we would say theta equals, we already know it's 45 because we've used our unit circle. But what if we don't? So then we know that theta equals cosine inverse of the square root of 2 over 2. And putting that into your calculator, you will be produced 45 degrees. So either way, you will get 45 degrees, whether you use your unit circle or whether you use your calculator. So that is angle between vectors. Don't worry, we're going to do another one. Okay. This time we're given the angle, we're given the magnitude, we're given the magnitude of u, the magnitude of v. We don't know the dot product. So what can we use to find the dot product of u dot v? Well, we can use the same formula that we just used on the previous slide. Filling in everything we know. Cosine of pi over 3 equals, we don't know u dot v, all over 10 times 20. Okay, 10 times 20 is 200. And to get that 200 out of the denominator, I need to multiply both sides by 200. So now I'm going to say 200 times cosine of pi over 3. Guess what, though? Pi over 3 is on my unit circle. So if I pull up my unit circle, if I don't have it memorized, I can still pull up my unit circle. I'm looking at the x component of my unit circle at pi over 3 because it's cosine, and that's 1/2. So 200 times 1/2 is 100. So u dot v is 100. And there's our answer. Remember that the dot product is a scalar, a simple number. So we should have a number as our answer, which we do here. We don't have a vector, we have a number. And that is what it should be. So that concludes our video for using dot product and finding angles between vectors.